dragon marking? It's an invitation.
If you've served in the Canadian Armed Forces or RCMP,
Hello everybody, Tristan here from Trisha's Hobbies. Welcome back to another stream. Today we are going to be doing something a lot different from my usual gaming streams. It's a Wednesday, a weekday, so I'm not going to be playing any games. I have a lot of homework to do, and I decided, you know what, why not just do it on stream? So, yeah, that's what I'm going to be doing. If you guys need any help, just text into the chat. I'll help you. What do you mean, Obito Wilson? Well, please tell me how to get better at quantum physics. Trish lied to us. He isn't helping us with homework. I am helping you with homework. I'm doing my own homework as well. But if you guys have any questions, I can help you anytime. I'm gonna be streaming for an hour or two, maybe 2.5 hours. I have a lot of math homework. So this is my, that was the wrong book. Here's my binder. Bruh. It's probably gonna be backward for you guys, so I'm sorry about that. But I'll be turning my page over constantly to just show you guys what I'm doing. How do you get good at quantum physics? Watch anime. My top tip to you. You know why? Because every single anime has a quantum physics plot twist. Highly recommend Bunny Girl Senpai.
What's studying?
Okay. It's a good. Square root of 679. That's just easy. Take out your calculator. Whip it out. That's illegal. Look at this. Square root of 679 equals to 600 square root of 679. Oh, it's 97. Oh, whoops. I'm so stupid. Wait. Still the same answer. 697. It's a scam and a half. How can you tell me the trigonometry equations? Yeah, isn't it a squared plus b squared equals c squared? Do you go to Saints? Sus. Yeah. For you guys that know who I am, I do. Just to stop watching anime and actually do your work, Richard Chen says. Been caught. Imagine streaming whilst doing your homework. Why not? Why not? Why not? You can do anything while doing your homework. Alright, I just have a little bit of popcorn in this tiny bowl. I ate most of it already. But chat, I am ready. If you throw an isosceles triangle out of the window of a car going at 40 kilometers an hour and it is Wednesday, what is the weather? Well, clearly, according to my calculations, I just did in my brain, and especially using the quadratic formula incorporated into the equation, as well as understanding the climate of the weather at that time, I would be able to predict that the weather during that time, especially because of the effects of the isosceles triangle being thrown out the window, my predictions are that it would be sunny with a 40% chance of precipitation. Tristan, is it bad if you ears are bleeding? Is that from me? If it's from me, no, you're fine. It's a blessing. If it's from somebody else, yeah, go see a doctor. Good advice. Trust me, I'm a professional. Alright guys, let's actually do some work. I have stacks of food. I have this strawberry like cracker thing. I have this like these Pretz sticks. They're like what do you call them? Pocky without the sweetness. Savory Pocky. And then my favorite, I have some Koala Smarts, which I've already eaten a little bit of. My favorite. What is the quadratic formula? Oh boy, you all are testing me today. I gotta remember this. I swear I remember. Give me some time. B squared. Wait, hold on. Wait. I swear I know it. Negative b squared multiplied by square root. Oh, I'm so stupid. Okay. Negative b multiplied by square root b squared minus 4ac over 2a. That's the quadratic formula. Whoa, whoa. Everybody, I'm on fire. I'm actually on fire. No, my ears are bleeding at the moment. Well, it depends what the cause of the bleeding ears is. If it's because of me talking, then clearly it's my blessing. If it's not because of me talking, then clearly you have to go see a doctor. If Mary has a little lamb, then what is MC squared? Well, according to my calculations, depending on the size of the lamb and measuring the area of its eye, then clearly you can make very, very accurate predictions on MC squared, especially based on the climate of the weather nearby, specifically New Mexico, which is south of where I live. And if you also incorporate the area of the moon, as well as the direction the moon is going, and the gravity, you can clearly find out that MC squared equals sub to Trish hobbies. I mean, I don't know if I'm a genius or anything. I've got 18 Nobel Prizes in the bank, so I don't know. To be or not to be, that is the question. To be or not to be, that is the question. It is a question. It's not a logical question. Shakespeare doesn't make sense. Don't know why we still like him. He's weird. I study him every day. I mean, every year. He's weird. If I spin around in the 90 degrees formula, how many dogs have I farmed? This is a math question, right? So, like, you know, not realistic. You're not farming dogs, right? Well, based on the stock market of yesterday, you can clearly analyze that the answer to this is 18.5 dogs. Oh, I suing you for assaulting my ears till they bleed. But you spelled suing wrong, I'm pretty sure. I'm pretty sure it's S-U-E-I-N-G, so. Message retracted. Alright, boys, let's actually, and girls, and everybody in between, according to Wally Bear. Let's get cracking. So, I'm gonna be doing math today. Mathematics. Maths. Math. Right now on pre-calculus 11, we are doing finance. It's interesting. Also, so here's my math right here. Probably can't see it. My writing is also super, like, you know, not very neat. It's not dark either. You probably can't see it. But we're gonna crack on. Just want to remind everybody, if you are enjoying the stream so far, make sure to drop a like and subscribe and drop any comments down below. Thank you. I would really appreciate it. If a man throws a pound of butter out of the window in 90-degree angle, what day is it? Well, the word butter rhymes with cutter. What's a cutter? A knife. What do you use a knife to cut? Vegetables. When did I buy vegetables last? Yesterday. Therefore, my equation leads me to believe that the day was Tuesday. I'm insane. Alright boys, let's go. Here's my desk. I have my mic here. My calculator. My pencil case. You open the front zipper. I have my eraser. And then my almighty pencil. I keep this paper thing over my pencil because I really like my pencil and I don't want it to be like dirty or stuff. And all the other garbage goes in here. Like sharpeners and felt pens and stuff. Okay, we'll put this away. This is also my math kind of workbook. Notebook. I'm disliking do your work. I'm doing my work. Don't dislike. Your teacher says it's Monday, not Tuesday. But clearly your teacher is wrong. Fine, I'll do my... Not Korean SG. If I do my work, are you gonna, you know, turn that dislike upside down, you know? You know what I mean? It'll be nice. Hello all 15 watchers, how are you guys doing today? Yeah, basically this is all the work I've been doing. I've been using my notebook because we were on online class for like a couple of weeks before, so that's what I use that for. But now he just gives us worksheets that we have to do, so I'm just gonna grind at it. Okay, finish question 1. What's the number of pi? Pi equals pi. Simple and easy. Or it's like 3.14156 something, I don't know. Yes, I already like, don't worry, okay. Yeah, also somebody said like, is your stream latency on low? Yeah, it is. Cause I think quality matters a lot. Everybody thinks my streams are slideshows, so I will prove them wrong today. Also, final thing to note, my sweater, 9 3/4, Harry Potter reference. I watched all the movies, didn't read the books. Swore to the Greek gods that I would only read Percy Jackson and never ever do Harry Potter. But I went to the wizarding world of Hogwarts and blah blah blah, so I had to buy it. We're done the popcorn and I haven't even done any homework. It was good though, from Colonel's. What are the first 50 numbers of pi? The first 50 numbers of pi. Florian and Jada are both investing $1,500. Florian invests in a GIC, which is a guaranteed something, which pays 3.1% per year, compounded monthly. Jada wants to invest in a mutual fund which promises 7% growth per year, compounded annually. However, the funds require a minimum investment of Okay, so these two are two different people right here. So you have Florian and Jada. Let me get a highlighter. So this is one person. Right, so this person is just doing that. And this person is doing this. I can't see anything I'm doing. That sucks. I'll just work. Alright, so let's work on Floriana first. Florian. Oops, I said her wrong name. Her name wrong. Alright, so we know that this is the principal. Principal equals that. The total amount is unknown. The interest rate, 3.1%. That's basically, end of 5 years. So that means that N equals to 5. This is compound. I spelled monthly wrong. Pain. So for you guys that are doing pre-calculus 11, or if you already have done it, hold on. If a cat kidnaps you, what velocity are you going at? Velocity is speed. But I think a lot of gravity has to play in that. I'm actually thinking this through. I think you're going at some sort of kilometers. Well, velocity actually in physics is measured in meters per second. So I'd probably say like 3,000 meters per second. If a cat kidnaps you, you're gone. You're gone. No one can get you. You're gone. Here we go. So guys, this is the question. If you guys want to do it along with me or not, probably can't do that. Okay. So, for you guys that are doing finance for pre-calculus 11, basically, when finding out compound interest, the equation you use is going to be A equals P multiplied by 1 plus I, or you can call that R, depending on what you want, to the power of n. Right here. Just like that. A equals to P times 1 plus I to the power of n. A stands for amount, the total amount of money you have in your bank account. This is including both the interest and the principal amount, this money that you start with. So basically, the profit you make and the starting amount that you first invested in. P stands for principal. Principal means the amount of money you just invested into your bank account. So let's say you invested $1,500 into your bank account. That would be your principal. And then at the total, at the end of the, like, let's say 2 years, you have $1,700. So that would be your A. That would be A, that's your amount. And the total money you make would be $200. And then you have 1 plus I. I would be your interest rate. Interest rate in percentage form or decimal percentage form. Usually it's pretty low. So let's say if you have a 2%, let's say 3% interest rate, convert that to decimal form, that would be 0.03. So 1 plus 0.03, and then you add that, you put it to the power of n. N is the number of terms you have or number of periods that you have. So if you have 5 years, you would put it to the power of 5. If you had 2 years, put it to the power of 2. When it gets complicated is if you're compounding monthly, annually, or quarterly, or semi-annually. So if you're like adding interest twice or 3 times a year, then you'd have to change that n to how many periods you have, and it gets a little bit more complicated then. But that's basically the basic premise of how compound interest works. Anyways, moving on. If we look at Florian, we have a principal amount of $1,500. We have here, let me show you guys better. Right here, right here. $1,500 is our principal. We don't know what our end amount is. That's what we're trying to find out. We have our interest rate, which is 3.1%, and it's compounded monthly, which means we have to divide this by 12. And then this is our n. So for 5 years, so we have to multiply that by 12. Because 12 times, you get your interest compounded 12 times in a year. 12 times 5 equals how many times you had compounded in 5 years. Alright? Plug everything into the formula and boom, you have your answer. So let's just do that. A would equal to principal $1,500 multiplied by 1 plus I. I is 3.1%. But when you convert that to decimal, that is 0.031. Bracket, and then to the power of n. So yeah, I already made a mistake here. Because I said it's 3.1%, but 3.1% per year compounded monthly. So that means 3.1% is for annual, 1 year. Compounded monthly means 12 months. So what we have to do is 0.031, which is our percentage, divide that by 12, and that gives you our real percentage. So that would be 0.0026, which is 0.26%. Okay, 0.026%. I think. Yeah, makes sense. 0.026%, rounded. And then 5 is our years. We have 5 years. If If you multiply that by 12, because we have 12 months in a year, you get 60. So N is actually 60. If you are Canadian and you have to go to America, how much sleep have you had? More than Americans on average. No joke. Let me show you my equation now. So we have A, our amount, we don't know what it is, equals to 15,000, which is our principal amount, the amount that this person invests originally into the account, multiplied by 1 plus 0.0026, which is 1 plus our monthly interest rate, to the power of, 60, which is 5 times 12. You can just plug this into your calculator. So 1.0026 to the power of 60 is whatever this big number is, and then you multiply it by 1500. Oh! It's not 15,000, it's 1,500. Good thing I caught that. Okay. 1500, okay? Multiply, and your total amount equals to $1,752.88. Okay, so this is the total amount that Florian has invested. We can take our ruler and then divide it so that we know who is who, and then at the end we can compare to see who made more money. Jada is gonna be a little bit more complicated because she has a weird thing going on. Hey, Jada. So basically, what Jada is doing is she's investing $1,500 into this account, okay? And this account has a 7% interest rate, which is like unrealistic, but it's a lot more than Florian, person 1. However, in order to invest, you have to put $5,000 a minimum. So she must borrow $3,500 from another. She must take a loan, and that loan has a 6% interest rate. So basically, she's borrowing money and putting it into account and making money there. But she also has a loan, which it has interest on her debt, so she's losing money there. And we have to find out who will have the most money and who makes the most money, basically. Ferdy's Gaming says hello. Hello, Ferdy. How are you doing today? Alright. So, let us start. So, our principal amount is actually 5,000. It's 5,000 for the 7%. So let's see. So we'll do first Jada 1. Principal is $5,000. Yes? Our A is unknown. Our total amount is unknown. Our interest rate is 7%, which is very good. Also compounded annual. Oh! Aha! This is compounded annually. This is a little bit of a trick question. It's compounded annually. So the 7% is compounded annually. But the 6% debt is compounded monthly. Okay, you tricky boy. N would be 5 years. So we'll just quickly solve this first. So we would have A equals to 5,000, our normal, multiplied by 1 plus 0.07, because it's 7% compounded annually, but you're only to the power of 5. So you're only doing it for 5 years. Yep. 5 times. That means that A equals to 1.07 to the power of 5 times 5,000. So she has $7,012 and 76 cents in her bank. I'll basically just show you guys. Right down there, that's what I did for Jada. 5,000 is the principal, don't know the amount. Interest 7%, compounded annually. The number of compound times is 5 because it's annually, 5 years. A equals to $5,000 principal multiplied by 1 plus 0.07, our interest rate, to the power of 5, which is N. And we get $7,012 and 76 cents. However, she has debt. So we'll do this part now. To Jada. Our principal is $3,500, right? Our A is still unknown. Our interest rate is 6%, which is a lot, compounded monthly. And then our time is N is 5 years. So we would have to do A equals to 3,500, and then 1 plus, it's compounded monthly, so 6%, 0.06 divided by 12. 0.005 to the power of 5 times 12, 60, right? Okay, so A equals to 1 plus 0.005 equals this to the power of 60 multiplied by 3,500. 4720.98. Okay. Alright guys, let me show you what I've done. So Jada 1, this is the amount that she is trying to earn. She made this much money, but she also made a loan, which means she loses this amount of money. So if you minus these two, you find out how much money she now has actually. And then you compare it and you see who has more money. So we write real amount 7012.76 minus 4720.98. She has 2291.78. So she has $2,291.78. And this is greater than Florian, who has $1,752.88. Therefore, comparing the two amounts, and we find out that Jada has more money. Now, one thing I'd always do. Let me get something up real quick. I have an answer key on my school website so that we can check our work after we are done. Let me get it up. I'm just not going to show you guys this yet. I'll show you guys after. I might have gotten it wrong. Probably have. Probably. Guys, look at this. Guys, look at this. Look at this, boys. This is B. Number 2. Jada will have more money than Florian after 5 years. 2291.76 to 1752.88. Okay, well, rounded a little bit off. But I basically got it right. Let's go. Alright, we're done number 2. We're done number 1. I already did number 1 at school. I'm done number 3. Filled out this little chart here. Into number 4. But I'm gonna take a quick break. I have to go do something quickly. So, one moment. I'm going to have the screen only and have this. Oh, I totally forgot to turn off my mic. I will see you guys in maybe 5-10 minutes. 7 minutes maybe. Hello, mateys, I'm back.
What did you do?
Okay. We want this one. Yeah.
Everybody watch you now.
Okay, I'm just gonna do some more work now. I'll just work a bit. Remember, any questions in the chat can help. Why do I feel like the lo-fi girl right now? From Chilled Cow or whatever. Okay, I adjusted my computer a little bit so you can see me and my work. Sort of. You can't really see my work. Almost. You can see my paper. Hey guys, so I'm just gonna do an update check with everybody. Show you guys what I've accomplished. So question 1 is already done at school, right? Question 2 I did together with you guys, very in-depth. Basically, yeah. Question 3 I did partly at school, but I also finished the bottom part where I had to explain a little bit. Question 4 was very easy. It was one line, literally. Question 5, easily done, also pretty short. Question 6 I had a little bit of trouble on, kind of, but it was pretty straightforward and pretty simple. I was able to do it, so that is it for my math homework. Very happy I got that out of the way. I'll put it into my binder and move on to the next homework. I'll see what I have to do, and then I'll see if I want to do that on stream or not. Oh, actually I do know what I need to do it. I actually do know what I need to do. And I think I will do it on stream, yeah? I have to do some more math homework. This one was a worksheet on what I have already learned, and then a math teacher assigns me, like, I don't know if you guys have heard of Khan Academy. It's something similar to Khan Academy, but it's called CEMC, and all of the stuff from it comes from the University of Saskatchewan or something like that, or sorry, University of Waterloo in Canada, which is where my teacher came from, so he uses that as a source. I'm just gonna do the be back, and I'm gonna fix this again. Alright guys, I'm back. I'm just gonna organize my desk a little bit. I'm gonna have a small break. Totally forgot my blue light glasses. Let me get that. BRB. Okay, I have my blue light glasses on. This is fantastic. We're gonna have a small break. I did that from memory. Did you? My homework? Interesting. Alright. This. Should we eat this? Or this? Oops. Or this? If you want to vote, say 1, 2, or 3, whichever one the first person says, I will eat it. 1, 2, 3. If I don't see anything in the chat, I'm going to cry. This one has been unopened. The other two have. I've never tried this before. I don't know what it tastes like. I had a vanilla version of it and it tasted pretty good, but I don't know how this tastes like. So usually I just take these small breaks like this. You know, just relax, chill, recollect, have a snack, and then resume. Nobody's saying anything in the chat. It's making me cry. I'm gonna have a little bit of this first. I love Koala Smart. It's so good. No thanks. Look at this. I'll show you guys. You see that? The tiny koala on a cracker. A little emote. 1. Can my Kozume says 1. Okay, I'll eat that. I'll show you guys first. Look. Take a small bite. Look at that. Inside there is chocolate. It's so good. Okay, we'll try this one. Pink strawberry flavored Japanese cracker thingy that I don't know how to open. Well, I did it. Look at this. So it opens up like this. There is 2 packages inside. Take the first one out. So here we have it. We can put this box to the side. There's one more in there for another time. Let me know, guys, how you open like these kind of containers or wrappers. Do you do the like tearing like this, or do the good old pulling like this? Personally, I'm not very good at doing this. I just tear it. There we go. See? We'll try. Smells like strawberry milk a little bit in there. So here we have our cracker, or a little meatball, whatever, cracker ball. You know what this reminds me of? It has filling inside and like stuff. It reminds me of profiteroles, or the more American way of saying it, cream puffs. Except these are smaller and they aren't cold. They aren't filled with ice cream. But they're similar and they're good to bring to school and they won't melt in your like lunch bag or anything. So crunchy and flaky, but the inside, it tastes like strawberry pokey or like strawberry milk. I know a lot of people don't like strawberry milk because it tastes not like strawberries, and that's true. But I personally find it tastes okay. It tastes pretty good. I would prefer chocolate over strawberry though, 100%. Here, let me see if I can show you. The inside looks like it's actually pink. Or, well, kind of. It's like a pink cream. Not filled up all the way though, so scammed, likely. It's good as a snack though. Screw it, I'm gonna eat all three. I'm gonna try all three. This one, actually unopened, so we'll try this later, we'll save it. Barbecue chicken flavored pretz. Expecting a lot from this. I love pretz, tomato pretz and stuff, so expecting a lot from that snack. Anyways, let's crack on to what we have to do today. Okay. I'm gonna be using this one today. Face cam with the sharing screen because I have some math homework to do. So go to Pre-Calculus 11. This is my homepage for all my homework, where I find all my studies, all the links I need. Of course, my profile picture is an Overwatch profile. Why? Because I want to. I don't play Overwatch, but I watched a lot of it. Okay. This is our homework. We finished problems at 21, which is what I just did. Now we have to do annuities. Sorry guys, but the lo-fi music has to go now. That's a resolution, it's not that good. Screw you, it's good. Oh! I didn't see this part, I'm sorry. But, that's very cool. Good job, Ken Kazumi. Alright guys, let's listen to this together.
In a previous lesson, geometric series were introduced. Recall that a geometric series is the sum of the terms of a geometric sequence. In other words, a geometric series is the sum of a list of terms in which the ratios of consecutive terms is constant. For example, 56 plus 28 plus 14 plus 7 and so on is a geometric series because it is a sum, and the terms of the sum have a common ratio of r equals half. In this lesson, we will look at a financial application of the geometric series formula.
Okay, interesting.
mali pa.
We'll put the snacks away for a little while. Last one. That makes sense. Equal monthly payments. Nice. General. Simple or general? General do. Name might be. Oh, I did it right. Okay. Nice. Okay. Tony, who says hi, Trey. Hi, Tony. How are you doing? I'm just doing math.
A spreadsheet is a helpful tool when analyzing annuities. Let's build a spreadsheet now to calculate the future value of an annuity. We're going to use a specific future value problem to see how the spreadsheet can be built, but the scenario we're given doesn't really matter. Sarah invests $1,250 at the end of every year into an account that pays 3.8% per year compounded annually. Determine the balance in the account after 5 years. Here's how we will set up the spreadsheet. Our first column will track which period each row is about. We could put the header of this column as year in this case, but period is more general. For instance, a different situation could have, say, monthly payments. We want this spreadsheet to track the balance in Sarah's account, so we need a column for the balance at the beginning of the period. In each period, there will be interest earned, so that is our next column. There's also a payment made in each period, so we need a payment column. And finally, we will have the balance at the end of the period. We require the balance at the end of 5 years. Therefore, the table will need to have 5 periods in it. At the beginning of year 1, the balance in the account is 0. The interest earned in year 1 is 3.8% of the balance at the start of year 1. We can write that with a cell reference formula as 0.038 times B2. Since there is no starting balance, the interest in year 1 is 0. Then we have a payment. So the balance at the end of year 1 is the sum of B2, C2, and D2, or 1,250. This amount becomes the starting balance at the beginning of year 2. As a cell reference, we have equals E2. Now that the spreadsheet has been set up with all of the proper cell references, we can use a fill down command in the spreadsheet to populate all of the entries in the table. The spreadsheet cells have been formatted to display 2 decimal places for dollars and cents. Before you continue this video, use the cell reference formulas to convince yourself that these values are correct, other than perhaps some slight rounding error.
So basically the formula is the balance at the beginning of the period, which would be $0 because he's paying at the end of the month. There's no interest because $0 and the payment is this. Add these 3 up and you get that. At the beginning, now you have this. There's this. And then you have that 3.8%. That's that. Then because this is the end of the period, you add it another again, and then you get that. So it keeps going. Okay. $1,001. $151,000. Oh, so adding more monthly payment, it's more money than percentage. Okay.
Earlier in this lesson, we developed a spreadsheet to calculate an annuity that was amassing a large sum of money in the future. It is also possible for an annuity to start with a large sum of money that gets reduced by the regular payment. A loan works in this way. Consider this situation. Misha borrows $5,000 at an interest rate of 5% per year compounded annually. Determine how long it will take to pay off the loan. Let's analyze this situation with a spreadsheet. Our first column will track which payment the row is about. We don't know how many payments will be needed, so for now we will just list up to 2 payments. Next, we will have a column for the payment. Then the next 2 columns show how the payment is applied to the loan. Some of each payment goes to the interest paid, and the remainder is the amount of principal paid. And finally, we will have the outstanding balance of the loan. Since the payments start at the end of the first year, we need a first row starting with payment 0. The only other number we need in this row is the outstanding balance, which is 5,000. As before, we have formatted the table to display money values to 2 decimal places. Now we move on to some payments. Misha pays $985 each year, so we can record that his first payment is $985. But the amount that Misha owes does not go down by $985, and here's why. Suppose Misha borrowed the $5,000 on January 1st. He doesn't make his first payment until the end of the year, on December 31st. So that means that interest has accrued during that first year, which Misha has to pay. The interest is 5% of the outstanding balance, or 0.05 times E2, which works out to $250. So if Misha borrowed this money from the bank, then when the bank gets Misha's $985, they first take the interest that Misha owes and put that into their own account. Then the remainder, the payment minus the interest, or B3 minus C3, That amount is what gets credited toward Misha's loan to pay off some of the principal. Thus, $735 is the principal paid by Misha's first payment. So of the $985 that Misha pays in year 1, $250 goes to the bank, and $735 reduces the amount that Misha owes. Therefore, the outstanding balance is the previous outstanding balance minus the principal paid, or E2 minus D3. Thus, Misha still owes $4,265. Next, let's fill down the cell references and the regular payment amount to the next row. Take a moment to convince yourself that these formulas are doing what we expect them to do. Hopefully, as you looked at the cell references, you noticed the following. The formula in C4 states that the interest is charged on the outstanding balance. The formula in D4 states that the principal paid is the value of the full payment minus the interest charged. And the formula in E4 states that the outstanding balance is the previous balance minus the principal paid. When all of these formulas are evaluated, we get these values. Since the outstanding balance is not zero, Misha still owes money on his loan. Thus, we need more rows in the table. And here they are. Notice that Misha still has a remaining outstanding balance of 59 cents. He could either arrange to pay this in the next payment period,
Oh, I was hearing a slight echo. I was like wondering what. Okay. 1 second, guys. I'm just gonna do something quickly. Okay, 1 second, guys. Okay. This is a little bit
the interest
complicated
on this
for me,
amount,
but I think
and this is known
kind
as a
of
drop
understand.
payment. Or he could
I'm
have
not gonna-
arranged to
When I have to solve problems like this, I'm not gonna be doing a spreadsheet or stuff. I hope there's like a fast forward formula that I don't need, like I can use. I don't need to do this. It's right here. Mom? Mom? Okay, 1 second, guys. I'm gonna be right back. Okay guys, I'm back. So compound interest. You may have done this. $2,000 is invested at 3.6% per year compounded quarterly. Determine the accumulated amount to 2 years. We've done this before. We've done that before.
Let's now solve for the future value of an annuity using the geometric series formula. We'll do so by revisiting the try this problem presented at the beginning of the lesson. At the end of every year, Ronan deposits $1,500 into an account that pays 4.8% per year compounded annually. If the starting balance was 0, determine the balance in the account at the end of the 8th year. Here is our approach. Ronan makes 8 deposits altogether, and we'll treat each deposit as a separate investment and determine how much each individual deposit will be worth in 8 years. So we will solve 8 future value compound interest problems and determine the sum of the future values of all 8 deposits.
Oh man.
We can visualize the 8 deposits using a timeline. The numbers across the top of the timeline indicate which year is being described, and the numbers underneath are the value of the regular deposits in each year. For example, the first number in the timeline represents Ronan's first $1,500 deposit, and the timeline shows that the first deposit is made at the end of the first year, as indicated in the try this problem. Now we will determine the value of each of these 8 deposits after 8 years at
1 second, guys. Okay. Man, this is pain.
the end of the timeline by solving 8 compound interest problems. We will start with the final deposit. Since Ronan deposits at the end of each year, this final deposit has no time to gain interest. It is deposited at the end of the 8th year, and the annuity lasts for 8 years. Thus, the accumulated amount of the 8th deposit is $1,500. Next, let's consider the second last deposit. The accumulated amount of the second last deposit can be calculated as a compound interest problem with these values. The principal is $1,500, I is 0.048, and N is 1. N is 1 because the second last deposit is made at the end of the 7th year, so it gains interest for 1 year. Then we write out the compound interest formula. We substitute our numbers and simplify. Let's not simplify any further than this. Stopping here will help us spot a pattern in the accumulated amounts of each deposit later on.
don't know if my leg is broken or not, guys.
One more?
Definitely is. Alright. How do I solve this? Okay guys, I just had to figure out how this equation worked, and I'm just gonna work on it quickly. I think I got it, but it's taking a long time. I think there should be a formula for this. Who's gonna explain the formula to me?
Let's include this result in our timeline. We now know that the second last deposit grows to an accumulated amount at the end of year 8 of 1,500 times 1.048. And let's now take a look at the third last deposit, the one made in year 6. We again need to know its accumulated amount at the end of the annuity. So we have another compound interest question to solve. The third last deposit is a compound interest situation with these values. The principal is $1,500, I is 0.048, and this time n is 2. n is 2 because this deposit is made at the end of the 6th year, so it goes through 2 compounding periods. Therefore, the accumulated amount of the third last deposit is calculated as follows. We write out the compound interest formula, substitute our numbers, and simplify. As before, we'll stop here with our simplifying. And let's add this result to our timeline. We could continue this process for all 8 deposits, but let's skip now though all the way back to the first deposit. We can determine its accumulated amount using the compound interest formula. It would be the same as the last 2 we did, except n would be 7 now, since this deposit is in the account for 7 years. Therefore, its accumulated value after 8 years is 1500 times 1.048 to the exponent 7.
Okay, yeah,
So we now have the accumulated amounts for each of the 8 deposits that Ronan makes. To find the balance in the account at the end of the 8th year, we require the sum of all of the individual accumulated amounts. So the balance at the end of the 8th year, which we will call the future value, is this series. Notice that this is a geometric series with a equals 1500, r equals 1.048, and n equals 8. And we know there are 8 terms in the series because Ronan makes 8 deposits. But we could also look at the exponents on 1.048. They start at 0 and count up by ones up to 7. So applying the geometric series formula, we first write out the formula and then substitute our known values. And we can evaluate the term inside the square bracket. When you continue the calculation, be sure you either carry many decimal places or use the memory feature of your calculator. Round-off error will be magnified when we multiply by a large number like 1500, and also when we divide by a number less than 1 like 0.048. Finishing the calculation, we get this amount. Therefore, Ronan will have $14,221.
I knew it. It's right here. Sn equals to a multiplied by r to the power of n minus 1 over r minus 1. I don't understand why it's the rn minus 1 part though. Because the formula is usually 1 plus I to the power of n. And a would be T1, right? I think that's what it's referring to. Or the principal amount, basically. Yeah. Oh, well, not really a principal, because the principal would be 0 when it first starts, so. Okay, here's what we're gonna do. Sn equals to a times, we'll make this big, okay, so oh, I get it. Oh, I get it. I do get it. Yeah. Okay, so this is so R would be the interest plus 1. So we'll have to minus 1 to kind of deduct that after. I think that's why. I think so. Okay.
Use. And we can evaluate the term inside the square bracket. When you continue the calculation, be sure you either carry many decimal places or use the memory feature of your calculator. Round-off error will be magnified when we multiply by a large number like 1500, and also when we divide.
It's an ordinary, simple annuity, which means that it will monthly, simple, ordinary, because she does it at the end, starting at the end of this month, so it's ordinary. And the annuity, it's annuity. You don't need to draw this timeline poop. You can just use the formula straight away. So yeah, R, the rate, is 1 plus I. See, 1 plus I to the power of n. But n is only 1, because using the first term. And then do this to the power of 36, which is n. And then this is a, which is the first deposit you put, tn. Not principal, because it's not 0. Charge. Okay. At the end of every year, $1,050 is deposited into account that pays interest at 3.5% per year. Let's try this one. This is number 2. So our A would equal to 1500. Our interest fee is 3.5%. Our I would be 3.5%, but that's not our R. That's not interest rate. Well, it is, but it's not R. Our N is 12. But this is years, and this is per year compounded yearly. Okay, so it's simple, original, whatever, ordinary, simple annuity. All right. What would be R? R would be, so 1.0 1.035, right? .035, I think. Yeah, that makes sense. To the power of n, which is 12 years. 1.035 minus 1 to the power of 12. What? Okay. So Sn equals 1500 times 1.035 to the power of 12 minus 1 over 1.035 minus 1. Which means that Sn would equal to the power of 12. So it's 12 here, so it makes sense. 212,902.94. 212,902. Yeah, that makes sense. Oh, whoops. Okay, no, I wrote the right answer here. I'll show you guys. I wrote the right answer. I just 21902.94. I wrote the wrong answer here. There we go. Okay. Let's try another one, actually. This is a little bit complicated. 2A. 2E can go here. 130. Quarter. We're both quarter. So the normal equation would be Sn equals to 130. You add 1, then you do it to the power 6 times 4 is 24. Then you minus 1. Then you multiply by 130. And then you divide. Uh-oh. 0.0352. Zero point zero 0.0088. That's 1.0088. But you minus 1, so it's divided by 0.0088. Sn. So Sn. Okay, Sn equals to 34570.
What's your name?
95. Three, 4, 5, 7, 0.95. I hope this is right. Yeah, let's go. Nice, we can move on now. Okay, there's some things I need to read here. Oh, I've been tired. I'm being tired. It's time for a small snack, I guess. What time is it anyways? 7:33 right now. See how this tastes like. It's not bad. Like, kind of strong, savory, salty, crunchy, a little bit spicy, but not really. Like spices, maybe pepper or something. It's pretty good. Okay. That A was a regular payment. Look at this. This makes sense. A little bit more sense. Okay. So as you guys can see, I am, when I do studying, I am very kind of committed to doing it. And I try and focus as much as I can. We don't have A in this question anymore. It's our R. So R equals to 1000. Our interest rate is 6%. And our years is 10 years. Our interest rate is 6%, 0.06. Divide that by 4 because it's quarterly. And that equals to 0.015 to the power of n. Power of n. So 10 years, right? That's 40 times. Minus 1. Put that over 1.015 to the power of 40 goes to this, minus 1 divided by 0.015. Oh, and then you multiply that by 1,000. 54,267 and 89 cents. 5, 4, 2, 6, 7.8, 9. There we go. Interest rate is 4%, and our years is 13, and it is every year, it's yearly. To the power of 1.04 to the power of 13 divided. Oh, I forgot the minus 1. Answer is 21614.89. Yeah, let's go. Okay. Oh. Man, that's a lot of homework. I still have 2 more. Oh, it's so much reading. is like working backwards now. One plus I to the power of n a. Trying to figure out what P is, the principal amount.
Let's try an example of solving for the present value of an annuity. Nicholas is going to establish a scholarship fund for his local high school. The fund will pay $2,000 every year for the next 10 years. The first scholarship will be awarded 1 year from now. How much does Nicholas need to invest today at 5% per year compounded annually to achieve his goal? Here is our approach. We will treat Nicholas' initial deposit as 10 separate deposits, one for each scholarship that will be paid. Then we will solve 10 present value compound interest problems to see how much Nicholas has to invest for each individual.
So he needs to invest some money, and it needs to grow 5% each year.
Individual scholarship. Finally, the sum of those 10 separate deposits is the total that Nicholas has to invest. As we did with the future value problems, we begin with a timeline. Since there are 10 payments in this annuity, we have 10 spots on the timeline. And we record underneath the timeline that each payment needs to be $2,000. So far, this is the same as with the future value problems. But to determine present value, we need to see how much needs to be deposited at the beginning of the annuity to make these scholarship payments possible. Thus, we need a present value column at the beginning of the timeline. We'll start by determining how much Nicholas has to invest now to pay the first scholarship 1 year from now. We draw an arrow from the future value of 2,000 back to the start of the annuity to an unknown present value, and we can solve this using the compound interest formula. This is a compound interest problem with a equals 2,000, I equals 0.05 divided by 1, because the compounding is done annually, and n equals 1. N is 1 because the first scholarship has 1 year to earn interest. We first write the formula, then substitute the values we know. This time we need to solve for p, so we divide both sides by 1.05 to the 1. Recall that we can write this instead using a negative exponent as 2,000 times 1.05 to the negative 1. Notice that we could have done these last two steps in just one step if instead of dividing both sides by 1.05 to the 1, we had multiplied both sides by 1.05 to the negative 1. As before, let's not simplify further so we can spot patterns later on. We include this result in our timeline. Now let's move on to the second scholarship payment. As with the first payment, we need to know this scholarship's present value.
Kinda just want to skip
So
forward
we
to
have
get
another
formula.
compound
I use
interest
that formula and I
problem
get
with
53,000.
a equals 2,000. This time we will multiply both sides by 1.05 to the negative 2. These two terms on the right side, they equal 1 when multiplied, since we would get 1.05 to the exponent 0. Switching the two sides around, we get that p equals 2,000 times 1.05 to the exponent negative 2. And we can include this amount in our timeline as well. Next, the present value of the third scholarship payment would be calculated in the same way, except with n equals 3, since the money for this scholarship payment goes through 3 conversion periods. Therefore, we get this present value for the third scholarship payment.
Not sure how you guys are.
Likewise, the
bearing
initial
with me
deposit
here. I'm
needed
bearing
for
with
the 9th
myself.
and 10th scholarship
this hurt.
payments are as shown here. We can now add these 10 present values to determine the total amount Nicholas needs to invest. This is the present value of the annuity. So the balance required at the start of the annuity is this sum. It is a geometric series with a equals 2,000 times 1.05 to the negative 10, r is 1.05, and n is 10 since there are 10 payments. We apply the geometric series formula. Here's the formula. We substitute our values. And just before we grab a calculator, let's multiply the 1.05 to the negative 10 into the square bracket. We leave the 2,000 where it is. Then 1.05 to the negative 10 times 1.05 to the positive 10 becomes 1.05 to the 0, which is just 1. Then we have to subtract 1.05 to the negative 10 times 1, which is just 1.05 to the negative 10. We can simplify the denominator too. 1.05 subtract 1 is 0.05. Next, we can grab a calculator and evaluate. Therefore, Nicholas needs to invest $15,443.47 now to achieve his goal. Let's end with some final remarks about this example. This situation is an ordinary, simple annuity. It is an annuity because there are regular payments. In this case, the regular payment is the $2,000.
You're kidding me. I have to do all of that. Okay, so R in this case.
Let's end with some final remarks. Present value for the third scholarship payment.
Because he's paying, so you're losing money, and that's.
Likewise, the initial deposit $2,000 times 1.05 to So the balance required at the start of the annuity is this.
This is the start of.
Sum. R is 1.05 and n is.
Okay, I think it's actually the same. Just when you're trying to figure it out. Your A. Let me think about this. So A is. A is T1, right? Yeah, so this is your first term right here. Right there. I know they can do the cheat thing. So your A is this. Oh, I think your A is just original. So your P times 1 plus I to the power of n, negative n. So what would you call? Future. That was future. Present value. Oh man, this is hard. This is pain. This is ooh. I'm gonna end at 3 hours. I'm probably gonna be finished by 3 hours, but I'm gonna end it at 3 hours because this is a lot of work. Get some more water though. BRB.
Stop na. Stop na.
It's not real.
Huh? Yummy, oh.
Okay, guys, I'm gonna have dinner. This is so painful. Oops, wrong thing. But I'll be back later. Continue doing homework. So, BRB.
Not getting any stream viewers? Oh, getting ignored.
Hello, everybody. Oh my lord, my savior. So I'm done my dinner. It was a good dinner. I didn't show it on stream like before though. But I'm gonna start continuing to work now because I am you know, just Okay, so let's go here. Keep on working. Right, there's a slight echo somewhere. I think it's from my stream. 1 second. Okay, we good. We good. We Gucci. This is my only homework, by the way. I just checked and I don't have any other, so I want to get it over with. So basically the equation is Sn equals to 1 plus I to the power of n, right? 8 initial amount so 8 times 1 plus I to the power of n multiplied by R, which is the same as 1 plus I to the power of n. R to the power of n minus 1. put that all over r minus 1. So r equals to I plus 1. Interest rate plus 1 to the power of n minus 1. Okay, yeah, this makes sense. Okay. Similar, but not the same. Oh, this is the formula I was looking for. Okay. PV stands for present value or whatever. Okay, so let's go to this one right here. So our regular payment, yeah. R is just gonna be the amount of money we put all the time. So, well, let's look at this number 4. Monthly. Okay. Let's see if I got this right. Yes, I did get it right. Nice. Try another. You just have to remember so many formulas. My teacher's going to give me them, but I still have to understand which one is which. only 6, right? Yeah. So there's this one and then that's it. Monthly.
Kung pala, hindi nakikita lang.
Plus I.
Diba? Ilan tayo? -1. Ilan na? 10 minus 1. Okay, and then yung phone mo nakaunda.
The power of n over 0.6.
One bedroom daw is about 550,000. Floor area is means 500 square feet depending on the floor. Okay. Parking and storage is included. Forward mo dito.
What? I was off by 1 cent because I didn't round it right. My calculator says I rounded it right. So fridge this dude. Ooh. This is the answer right here. This is the answer I gave. Look at it. It's the same thing. It's off by 1 cent. I hate it. This. No. Well, I'm gonna say I got it right. There we go. I got it right. Definitely. Interest 6%, and it's 3 years. Percent equals to this. Quarterly, so 0.06 divided by 4. Nice, okay, we got that one right first try. Very cool.
Anyone have a suggestion? I must have please. Somebody's asking, does any about the
I don't think I need to do this anymore. This is just This is just application of it. I think I'm done my homework, everybody. That was a long stream, everybody. Oh man, but I'm so glad I am done that. I'm gonna do this. Alright. Guys, look at how much homework I did. So, this page, and some of this page. Might not seem like a lot, but it was like mostly understanding the concept and excuse me, just trying to read a lot. You know, there was a lot of reading. I mean, just look at this. Just look at this. Look at how much, you know, how many articles there are, and each article is so long. So, you know, it spends a lot of time, and not only that, but I also did that homework before. So, you know, it's a lot of homework to complete with math. But I don't have any other homework for anything else, so I am so glad I am done. I think I'm gonna end the stream there because I've been streaming for what, 3 hours now? 3.5 hours. Holy cow! Not quite like 4 hours I've done before. It's like still a long time. So I'm just gonna say thank you so much, everybody, for sticking around and watching this stream. I know it might not have been the most entertaining or fun stream, but I really hope you guys did enjoy that. Let me know down in the comments if you still want to see streams like this, or if you want to see more gaming or more like vlogs, and just basically tell me what kind of content you want to see coming out of me. Yeah, so I think I'm gonna do the stream, end it there. My name's Tristan from Trisha's Hobbies. I'll see you guys later, but make sure to leave a